Lesson 10.11 is called partial fraction decomposition. And you're thinking, what the heck is that? Well, we have what is like an answer, and we're trying to break it up into two fractions that got either added or subtracted to make that answer. The process, once you get the hang of it, is not really that bad. Okay, so what I want to do first is actually factor this denominator. So I know what the two fractions are going to have denominators of. So let's see, that's a basic trinomial. I know it starts with x times x, so that would be 4 and 5. And I'll just put the -7 back on top. So this is really the step kind of before it gets this answer. I'm going to set that equal to two separate fractions. One fraction is going to be something, so I'll just call it a over x plus 4. One of the factors, plus, always plus, and then I'll do something else, call it b, over the other factor. So it wouldn't matter if you have these switched up, you would end up getting the same final answer, just maybe in a different order than me. Okay, so then from here, we have to figure out, how do I solve for a and for b? Well, I want to get rid of my denominators, and the way to get rid of all of these in one clean sweep is to take this whole thing times the common denominator, which is these two factors that are occurring. So I'm going to take the whole thing times x plus 4 times x plus 5. So what's happening is really that is over 1. And so I would have -7 times these two things, then being divided by these two things. Let me pause and I'll write that out so it makes more sense to you. That's what it would look like. So I'm taking -7 times these two factors in the numerator over 1 times these two factors in the denominator. So the x plus 4s are canceling and the x plus 5s. It leaves me simply with -7. So you're looking for the factors to diagonally cancel. So that would give me -7. And then here, my x plus 4 factors would diagonally cancel. So then I'll have a times the other factor of x plus 5. You don't want to distribute. You just want to keep them like that. And then plus x plus 5 factor would cancel diagonally, so then I would be taking b times the other factor of x plus 4. So hopefully that makes sense to you. So that at least made it look quite a bit better pretty quickly. Now I want to solve for either a or b, and I can't solve an equation with two variables in it. One of them has to go away. And so the way to do that is to strategically pick an x value that makes one of them go away. So for example, this x plus 5. What x value could I plug in here to make this become 0? It's kind of like when we had quadratics and we set the factors equal to 0 and solve. We'd subtract 5, and so x would have to be -5. It's easy to just look at it and say, okay, well, -5 plus 5 makes 0. So that's what I'm going to plug in first. So if x were to be -5, I would have -7 equaling a times -5 plus 5 plus b times -5 plus 4. -5 plus 5 is 0, times a is 0a, so it just goes away. You'll get to where you just don't even show that step. I have -7 equals -5 plus 4 is -1b or -b, so I divide by -1, which gets b is 7. So that found the number that's going to go on top of this fraction. Okay, so there's half of it. Now I want to look at the other factors. So what number plus 4 would make 0? -4. That's what I'm going to plug in for x. So I would have -7 equals a times -4 plus 5 plus b times -4 plus 4. This is 0b, so it's gone. I have -4 plus 5 is 1a or a. So a is -7. So these two are my important pieces. But your final answer is going to be these two fractions. They want the fraction decomposition. You're decomposing it. You're breaking it apart. So if this is my a is -7, it'll be -7 over x plus 4 plus my b is 7 over x plus 5. Final answer. And you could see where if I were going to add these fractions, I would get a common denominator, which means I would multiply these two. And that's what we said was happening here. Then you would have to make equivalent fractions and add your numerators, and they would all simplify to make -7. So it's kind of cool. Let's try number 2, and we'll go a little faster. Only thing different about this one is it's a slide and divide factoring in the denominator. So to factor this, I take 2 times 6. I'll show the work over here. X squared minus 7x. 2 times 6 is 12. Factor this like normal. When I have to have 2 negatives. 3 and 4. But don't forget to go back and divide by 2. So I have x minus 7. I guess that's the other thing that's different is we have a binomial in the numerator. And then we slide the 2 back up. So this is actually 2x minus 3 times 4 divided by 2 is just 2. So x minus 2. So that's the step before it became this. Set this equal to some number, so I'll call it a, over one of the factors plus b over the other factor. That's the equation that's going to help us solve for a and b. Now to solve it, first step is to get rid of the fractions. So you're going to multiply by this denominator here. So think about this is over 1. So this gets multiplied by the numerator and then divided by the denominator. So this cancels out. You're left with just x minus 7. 2x minus 3s would cross cancel. So you have a times x minus 2. And then x minus 2's would cancel. You'd have b times 2x minus 3. Okay, then the next step is to pick x values that are going to make your a or your b become 0. So first, the easy one is thinking what number minus 2 would make 0 would be 2. So we would have a 2 minus 7 equals 2 minus 2 is 0a. I'm just not even going to write it. And then b times, let's see, 2 times 2 is 4 minus 3. 2 minus 7 is negative 5. 4 minus 3 is obviously 1, so b is negative 5. I'll circle it. So that's half of it. All right, the second one, 2x minus 3, kind of comes back to here. Thinking what number minus 3 halves would make 0? Positive 3 halves. If you can't figure that out, think about setting it equal to 0 and solving it. You get that x would need to be 3 halves. Okay? And so I'm going to plug that in, which 3 halves is actually 1.5 if that helped you. So 3 halves minus 7, 3 halves minus 2, and then here this would be 2 times 3 halves. The 2's cancel, so that's 3 minus 3 makes 0. That's why that one's going to be gone. Okay, I'm going to do it by hand because I kind of enjoy it. 7 over 1 would be the same thing as 14 over 2, 14 halves. And then 2 over 1 would be the same thing as 4 over 2, 4 halves. So this would be 3 minus 14 would be negative 11 halves equals 3 halves minus 4 halves would be negative 1 half a. And then I'm going to multiply by the reciprocal, which would be negative 2. Negative times negative is a positive. 2's cross cancel, so I get a is 11. Now your job is to simply put them into the fraction. Sorry I have such a mess here. I'll write it up here in the middle. So my a, make sure you put it with the right fraction. I got 11 over 2x minus 3 plus. So you have options here. You can put plus and then negative 5. That's normally what I do. Or you could put minus 5. I'm going to do plus negative over x minus 2. But again, if you just wanted to make it be minus 5 over x minus 2, that's fine. Either answer. So again, if I did this operation here, I would end up back with this answer.